Hello, everyone. So I'm going to go over three questions that came up to me from several students of Math 111 and Math 112. And so this question over here, question 5, is from the 2018 review. So let's see, it's an optimization problem. So should be pretty simple. Let's see. All right, so we have a piece of wire 2 feet long, okay, is cut into two pieces, and one piece of length x is bent into a square, and the other of length y is bent into an equilateral triangle. Using the fact that the area enclosed by a square of side length s is s squared, and that enclosed by an equilateral triangle of side length s is radical 3 over 4 s squared, answer each of the following questions, and where appropriate, verify your responses using the appropriate tests and results. Okay, so for this problem, what I did was that, well, first, let's draw the piece of wire. So we have a piece of wire that's 2 feet long. Okay, so this over here is 2 feet long, right? So we cut this in half. Well, not really. We just cut it in two pieces. And then one of the sides of the wire is going to have a length of y, and the other side is going to have a length of x, right? And so we know that because it's 2 feet long, then x plus y equals 2, okay? And so if you want to solve in terms of y or x, you could have y equals 2 minus x, and so on. Okay, and now for the area of the squared, right, the area of the square is just going to be something like this. It's going to have an area of s squared when each side, okay, is going to be side of s. But then we're told that the piece of length x is bent into that square, so that means that the perimeter of the square has to be equal to x, right? So that means that since we have 4s in here, because we have 4 different sides, so 4s equals to x, right? And so what can we say from this? Well, we say that s equals x over 4. Okay? And so if we want to find the area in terms of x, then you can say that the area, okay, of the squared equals to s squared equals to x squared over 16, 4 squared, right? All right, so that's one part of the question. That's on part A. And now for the equilateral triangle, we have something like this, right? Each side has a length of s over here, and the total area is radical 3 over 4 s squared. So we're told that the piece, okay, that has a length of y is bent into this triangle, meaning that the perimeter of the triangle has to be equal to y, and since we have 3s, okay, in total, so that has to be equal to y. So we solve in terms of y, s equals to y over 3, in the area, which is the area of the triangle, which is going to be radical 3 over 4 s squared. In terms of y, that would be radical 3 over 4, and then y squared over 9. 9 times 4 is 36. So the area of the triangle is radical 3 over 36 y squared. Okay. For part A, we're asked to derive a formula for the sum of the areas enclosed by the square and the triangle. They're not specifically asking to answer in terms of just one variable, so we're going to use, okay, both definitions that we just found. So the area, the sum of the areas is going to be equal to this area plus this area. So it's going to be x squared over 16 plus radical 3 over 36 y squared. So that would be the sum of the areas. Now, keep in mind that the total length is 2 feet, okay? So that means this formula still holds as a relationship between x and y. Now, for part B, okay, so this was part A. For part B, we're going to find the absolute maximum and minimum of the area and the points at which they occur. Leave your answers in the form of a ratio, possibly involving radical 3. Okay, let's see what we can do. So for this problem, what I did was I took the derivative of the area, right? In terms of x, because usually, it's standard to just go ahead and take a derivative in terms of x. So we can say that dA over dx is equal to, okay, in this case, x squared over 16, and then the differentiated is going to give you x over 8, right? And then plus, okay, radical 3 divided by 18 times y times dy over dx. Now, dy over dx has a value. Remember that we're told that the sum of x and y is equal to 2. So we can find dy over dx. And dy over dx is equal to -1. So we can use this relationship in order to find the absolute maximum or minimum. So dA over dx equals to, okay, x over 8 plus or minus, because it's being multiplied by -1. So it'll be minus radical 3 over 18 times y, okay? And then if we set this equal to 0 to find the critical point, okay, in order to find the critical points, then we're going to have, okay, y. We can solve it in terms of x as well. So we can have x equals to 8 radical 3 over 18 times y. Okay, 8 divided by 2 is 4, and 18 divided by 2 is 9. So we have that x equals to 4y divided by 9. So when x equals to 4y over 9, okay, I'm sorry, 4 times radical 3y. So when y is equal to 4 radical 3 times y over 9, then we have a maximum area. Okay, so you can visualize it. Okay, you can visualize it by substituting the value of x. Okay, by substituting this value over here into x. But to do that, you have to solve s in terms of each variable, and we did that already. We found that s equals y over 3 for the triangle, and that s equals x over 4 for the square. So if we were to look at the square, right, we know that for the square, each side is x over 4. X over 4. Okay, and so when we find that 4 radical 3 over 9y equals to x, we can substitute that in there to find the area. So if the area of that square, okay, is going to be x squared over 16, right? It's going to be x squared over 16. Then if we solve that in terms of y, well, that's just going to give us 4 radical 3 over 9 squared, and then times y squared over 16. So that would be the maximum area of the square. Now the maximum area for the equilateral triangle, since we found that each side is y over 3, right? Y divided by 3 is each side, and the area of the equilateral triangle is radical 3 over 4 s squared. So each side being s, so we have radical 3 over 4 y squared over 9, and so we substitute our value of of x in here, right? So if you want to find the area in terms of x, when this is a maximum, right? So when you'll have to do it the other way around. So you solve for y in terms of x. So you have that y equals to 9x over 4 radical 3, and then you can substitute that in here, and you find that the area of the equilateral triangle, wait, it's going to be, okay, radical 3 over 36 times 9x over 4 radical 3 squared. Okay, so those are the, that's what happens when the area is at a maximum. And the minimum area is, well, when both areas equal to 0. So the minimum area happens when x equals 0 and y equals 0. And I mean, that's just common sense. Because what happens when the length of the wire is just 0? Well, you have no area. You have 0 area. And you can't have anything less than that, because area cannot be negative, right? So you say that, you can say that the absolute maximum, right? So if you were to answer this problem, you can say that the absolute max area happens or occurs, okay, at x, right, or at y equals to 9x divided by 4 radical 3, and that's a ratio, right? So I think that works. Okay, so, and then the minimum area, the absolute minimum area, absolute min, okay, occurs at y is equal to 0 and x equals to 0. Okay, so we got that. Now let's go over two questions that came up from Math 112. So now we're moving to Math 112. One question was, well, it was just a telescoping series that I wasn't I didn't answer right on the review. I forgot to answer. I don't know why, I just skipped it. But it was something like this. It was the sum, okay, from 1 to infinity of 1 over n squared plus n. This can be factored as the sum from 1 over n times n plus 1 using partial fraction decomposition. The question was to find the sum. Find the sum. Now, we use partial fraction decomposition, and then we say that a over n plus b over n plus 1 equals to 1 over n times n plus 1. Then we let n equals 0, right? So if we find the least common denominator over here, we have that a times n plus 1 plus b times n equals to 1, right? So this is what we find from the common denominator. And so if we let n equals 0, we find that a equals 1. Okay, we substitute 0 into this equation for n. Now, given that a equals 1, if we let n equals to, let's say, negative 1, right? Because that will get rid of the a, then b has to be negative 1. And then here I stopped on the review. I don't know why. But anyways, I'm going to finish this here. And so we find that this is basically the sum from 1 to infinity of 1 over n, right? So 1 over n because a equals 1. And then minus 1 over n plus 1. Now, this is a telescoping series. So in order to find the sum, what we have to do is write out the first few terms and see what's the pattern. Usually for telescoping series, the terms will cancel out in the middle, and then we're left with a final, okay, a definite answer. So this is going to be, for n equals 1, we have 1 over 1, right, minus 1 over 2. For n equals 2, we have 1 over 2 minus 1 over 3, okay, oops. For n equals 3, we have 1 over 3 minus 1 over 4. For n equals 4, we have 1 over 4 minus 1 over 5, and so on. So on until plus 1 over n minus 1 over n plus 1, which is your nth term. So what happens here is that this negative 1/2 cancels out with this 1/2, and then this negative 1/3 cancels out with this 1/3, this 1/4 with this 1/5 with whatever is going to be next, and then the 1 over n minus 1 term will cancel out, okay, with the 1 over n, and we're only left with this and 1. So we can say that the sum, okay, Sn equals to 1 minus 1 over n plus 1. And so to find the value of the sum, we have to find the limit of the sum as n goes to infinity. Limit of the sum as n goes to infinity is the limit as n goes to infinity of 1 minus 1 over n plus 1. This goes to 0, so we're left with 1, and that's the sum for the telescoping series. Now, the last problem that came up on Math 112 was a kind of like a geometric series on steroids, so it's kind of like a weird problem, but it's something like this. So it's basically the sum from 1 to infinity of 4 to the n plus 5 to the n over 3 to the n plus 4 to the n. Okay? I believe that's how the problem went. Or maybe it was backwards. Yeah, because I don't think this will converge. So let me do it backwards. Yeah, that's probably how the problem went. So it's going to be 3 to the n. Yeah, so 3 to the n plus 4 to the n divided by 4 to the n plus 5 to the n. Okay, and then we're asked to find the convergence or divergence. So does this converge or diverge? Okay, so we say that. So what I did was I found that, you know, a comparison test is the best for this problem. Limit comparison test will fail, okay, because it would be too complicated to find something that will, you know, cancel out nicely. But I think the limit comparison test can do. Yeah, so let's see. I mean, we could say, so we say that A sub n is going to be this series, this sequence inside the series, so 3n plus 4n, right, divided by 4 to the n plus 5 to the n. And then for the Vn, what I did was I compared it to whichever, you know, just to some values so that I could somehow cancel out the top or bottom. So I just compared it to, for example, the highest powers. So I compared it to the highest powers on the numerator and the denominator. So 4 to the n and 5 to the n are the highest powers. So I compare it to 4 to the n divided by 5 to the n. Okay, and then we know that a sub n is greater than 0, b sub n greater than 0, for n is greater than or equal to 1. So those are the conditions for the limit comparison test. So that means we can take the limit as n approaches infinity of a sub n over b sub n. That's equal to the limit as n approaches infinity of 3 to the n plus 4 to the n divided by 4 to the n plus 5 to the n times 5 to the n over 4 to the n, right? The reciprocal of Vn. And so here I got a little bit confused at first because I thought, well, can we actually combine these terms? And basically you can. You can combine 5 to the n with 3 to the n and 4 to the n. Because if you think about it, 3 squared, right, times, let's say 2 squared, is equal to 9 times 4, right, which is 36. And we can say that that's basically 3 times 2 squared, which is 6 squared, which is 36. So that works. So you can combine them. So what we have is the limit as n approaches infinity of 3 times 5 is 15 to the n, plus 4 times 5 is 20 to the n, divided by 4 times 4, 16 to the n, and then finally 20 to the n. Once again. Now over here, what we'll do is divide by 20 to the n on both top and bottom, and then we get that this is the limit as n approaches infinity of 15 over 20 to the n plus 1 divided by 16 over 20 to the n plus 1. Now, as n goes to infinity, this fraction, which is less than 1, will approach 0, and this fraction will as well. So we're left with the limit, okay, is equal to 1. And according to the limit comparison test, if the limit of a sub n over v sub n is some value c that is less than 0, in which case it's true, 1 is less than 0, then either bn and bn both converge or diverge. So we know the convergence of v sub n. If v sub n is 4 to the n over 5 to the n, and the sum of v sub n equals the sum of 4 to the n over 5 to the n, we know that this is a geometric series with absolute value of r is less than 1, right? So when that happens, we say that it converges. It converges to some value. So this sum of v sub n converges. Therefore, the sum of a sub n converges as well. So that will be the answer. I think that's it for now. Thanks for watching. Good luck on the exams.